Hello, my dear all audience. Today again I came up with a new video, that is the second part of the elimination of the drug. In the first part, we have discussed about the biotransformation and all the phases, and cumulatively the excretion and biotransformation togetherly are completing the process of elimination, because until and unless the drug has to be gone through the phases of biotransformation, it is very much difficult for that drug moiety to get out or to excrete or to eliminate from the body. And because it is a exogenous substances, only for the curative purpose or maybe sometimes for the protection purpose, we are consuming so many kinds of chemical substances, as like we are consuming food substances for the better health of our day-to-day life. So same as like in case of to secure our life from different kind of infectious attack, or to cure different kind of ailments, we will choose to have some kind of drugs as a nature of chemical substances for a foreign bodies. It has to be excreted after a definite period of time by showing its activity, and that activity should be a therapeutic activity. So sometimes this therapeutic efficacy of the drug may become noxious, or sometimes may it create some kind of unwanted effect rather than a therapeutic effect. Wherever there will be something, changes will happen with the phases of pharmacokinetic. There is nothing but the absorption, distribution, metabolism, excretion. In all the phases previously that we have discussed about the like absorption or distribution, different kind of factors are responsible, which may be physiological, maybe sometimes it is chemical, the drug itself or the physiology of our own body itself creating some kind of impacts upon the phases of the pharmacokinetic, which really create an impact or can alter the smooth process of the disposition of the drug, through which this kind of unwanted effect may happen. So we must be aware about all of this pharmacokinetic process, because until and unless we don't know how the drug is traveling throughout our body, then we will never find out what it should be, the dose we have to take, what should be the frequent dosing time it should be there, and what kind of harmful consequences will be there if the drug will not administered combinedly, or a combination therapy, it will create some kind of unwanted effect, which may really threatful things for patient or for subject. So excretion is the last phase, you can say, in the pharmacokinetic phases, and that should be after the drug has shown its pharmacological activity. Because as I told you earlier, the pharmacokinetic is the initial process to show the pharmacological activity by a drug moiety. But whenever the drug will show its activity at the tissue site or the site of therapeutic action, it has to be excreted by the kidney, preferentially from the body through urine, most preferable way of excretion route. Otherwise it will remain inside of our body, and if it will remain for a longer period of time, it may be harmful. So now I hope all of you are in a good health situation. I hope we are extremely fighting against of this pandemic situation of COVID-19, which is really an epidemic become worldwide. So we will be also excreted out this situation in one day. We will be soon excreted from this situation. So the life has not been stopped, and we have to be move forward. So in excretion, what is this actually? This is nothing but the removal of pharmaceutical items. Pharmaceutical items, the drug that maybe you are taking as a dose, different doses form. Maybe you are taking as a patches. Maybe you are applying as a ointment. Maybe you are taking as a syrup, as a suspension, as an emulsion. Maybe you are taking as a tablet, solid doses form. Whatever the pharmaceutical items you are taking, because it's having some kind of medicament, it's having some kind of drug. That means it's having some kind of chemical, which amount is therapeutic for you, but it has to be excreted after a stipulated period of time from the body, because it can't be remain for a longer period of time. If it will accumulate within your body, it will be threatened. So in this way, typically consists of two key components. The drug has to be excreted. What are these? Excretion and biotransformation. We have already discussed about this biotransformation. Nothing but the conversion of the drug into a more polar moiety. That means the drug will be more becomes water soluble. That means there will be more dissociation. That means there will be more ionization of the drug. Why? If it will be dissociate more fast, it will be soluble in the water more fast, like an NaCl, Na plus plus Cl minus. Same way, the biotransformation is helpful to make the drug moiety into that water soluble moiety, so that it can be easily excreted through the urine, because urine has nothing but the aqueous phase, the body fluid, the water volume, and within the body fluid the drug is actually dissolved. So biotransformation is the first phase. If you concise our thinking area within the elimination period, then biotransformation is the first phase that has to be done by the liver, especially because cytochrome P450, the cytochrome enzymes, we have already detailed about, gone through that the classes. So many other organs are also having this enzyme. That's why some other organs also have partially having an ability to detoxify some kind of drugs, some amount of drug in some extent. But liver is the major organ, as like kidney is the major organ to excrete the unwanted substances, unwanted electrolytes, waste products from our body. Otherwise, this kidney, sweat glands are also there. We are also inhaling, exhaling carbon dioxide. So some kind of volatile substances also come out from our body, also excreted, also eliminated from our body through this respiration process. Then some kind of drugs are also excreted through the feces. So these are different kind of excretion route out there. So the elimination of the preserved medication is the excretion of drug. Nothing. So non-volatile and polar medications are often excreted through renal excretion, which contributes to the kidney and eventually to urine. Actually, who is the main organ for the formation of the urine? Kidney. So non-volatile medicine, that means those are not volatile. Those can't be excreted through the respiration process. So non-volatile medicine, the excretion of the medication into the bile, other routes, blood, spit, milk, by lactation process. That's why some mothers who are being pregnant or who has already birthed a child, so the child may possibly get some kind of medicines that the mother also consumes. So during the pregnancy time, it is very cautious to prescribe. Or other body fluids can also be another means of removing drugs, as I told you. So volatile medications are excreted through the lungs into expired blood. That means when it's actually exhaling like carbon dioxide, like ethanol, it's exhaling through the respiration also. So including gaseous anesthetics, narcotics, and medicines with high volatility, they will excrete like in this way. So both lipid soluble drugs are turned into water soluble substances to be expelled from the body through metabolism. As I told you, metabolism in the initial phase. So upon biotransformation of the medication action, the therapeutic substance may be excreted. It may also be concluded that both metabolism and excretion are essential for a medication to be excreted from the body. Yes, if you consider about the excretion, metabolism and excretion, both are conjugatively working on this process. So what is this clearance? The word clearance defines the substance removal method. Clearance is nothing but substance removal method. It's a method from the body or from a particular organ without the procedure involved. That means procedure is not the essential thing over here, in which process it is excreting. The thing is, it has to be excreted. And clearance is nothing but the substance removal method. This is also called body clearance, or maybe you can say total body clearance, and abbreviated as a CL or CLT. CLT is nothing but the total body clearance. It can be defined as the fluid volume excreted from the product per unit of time. From the product, that means the drug. So what is clearance actually? The fluid volume of excreted from the drug per unit of time. How much fluid is excreted from the drug fluid? That means by containing the drug. That means which is the which fluid? In that fluid, what the drug has already been dissolved. So the clearance units are often recorded every minute in milliliter, like ml per minute, and also commonly liter per hour. Whenever ml, consider it minute; whenever liter, consider it hour. But there is a per time. We'll consider the time. So the definition of quantity is clear and realistic because all medicines are absorbed and spread in the body first. Obviously, until and unless we have studied in the distribution that if it is not distributed in the body fluid, it will not diffuse into the tissue, and if it will not diffuse into the tissue, it will remain into the polar stream, and that means no therapeutic action. Basically, generally. So the basic definition of clearance: consider the body as a vacuum, as a space, as an open space. For what? In which a specific volume of apparent body fluid, BD, is extracted, in which drug is distributed. So drug clearance shall be described as the fluid fixed volume that is extracted per unit of time from the product. That means excreted. Extracted is nothing but the excreted. Here extracted defines this excreted per unit of time from the product. From the product, that means the drug dissolved volume. That's why it is volume per time. So is the metric of clearance. So for example, now be concerned about this example. If the clearance of penicillin in a patient is 15 ml per minute, what I am saying, 15 ml per minute is the clearance of penicillin for a particular patient or for a certain patient, and the BD of penicillin is 12 liter. So that means 15 ml of the 12 liter are excreted from the medication per minute by the clearance description. That is the clearance. That means 15 ml from the 12 liter will be excreted. That is saying fluid volume excreted from the product per unit of time. From the product, here it is the 12 liter. From that 12 liter, 15 ml per minute will be excreted. That is nothing but the clearance for the particular penicillin for a certain subject. And subject to subject, this may vary. Why this will vary? This may vary due to different kind of causes, different kind of factors may acting upon that particular subject. But this is the clearance. This is the method of the clearance, and this is called clearance. And be attentive and be remember, clearance and excretion rate, these are two things. These two things are not equal thing. Excretion rate, that means how much amount of drug is excreted per unit of time. That is excretion rate. Clearance, how much amount volume is eliminated from the total apparent volume of the drug, or the volume where the drug has been dissolved. So CL can also be described as the rate of drug elimination separated by the concentration of plasma. So this term is used for the processing of drug as regards the amount of plasma extracted per unit of time for medication. So it is a realistic method of measuring clearance on the basis of concentration evidence. That means if you know what is the concentration of the plasma, you may able to find out what is the clearance, as well as if you know the excretion rate and if you know the half-life of the drug, how you can find out. Just coming to the next point. Now according to the definition, clearance is nothing but the elimination rate divided by plasma concentration. So what was the elimination rate? dDE by dt here. Here dE, that means is the amount of drug to be eliminated. So with respect to time, the fraction of change of the amount of drug to be eliminated is the elimination rate. So now rearranging the equation, we will get below equation. What is this? That elimination rate, that means if we consider elimination rate dDE by dt, we can say it is nothing but that Cp into Cl here, because Cl is equal to d elimination rate by plasma concentration. So what is elimination rate? Plasma concentration into clearance. You can write that. But according to the first order elimination rate, dE by dt, that is the elimination rate, is equal to kdV, the total body distribution is nothing but the apparent volume of distribution into plasma concentration. So here K into Cp Vd. So substituting this, that means if we put this into here K Cp Vd, then Cl is equal to, will get that, then Cp will be eliminated, then we can get clearance is equal to K is nothing but the elimination rate constant into Vd is nothing but the apparent volume of distribution. So what we can get? The rate of elimination of drug, that is dE by dt, increase appropriately, although the concentration of plasma medication increase during elimination. That means actually here it is trying to say that whenever if you are trying to relation between plasma concentration with the elimination rate, then it is proportional. Why it is proportional? Because if plasma concentration will increase, the elimination rate also will increase. So clearance is stable as long as first order phase is the speed of the clearance of drug. So here clearance will never change. Clearance will remain constant until the process is followed the first order. Now how it is possible? It will be more clear by this problem, by solving this problem. Let's think, just think about that. The penicillin has a clearance of 15 ml per minute. Okay, calculate the elimination rate for penicillin, and they have been given to you. That is the plasma concentration. That is the 2 microgram per minute. Very easy solution. What we need to do? Nothing but just put the values in the equation. We know that elimination rate is equal to Cp into Cl from equation 7.5. That means Cp into Cl. This is the elimination rate is equal to Cp into Cl. So we have got, here is the elimination, here is the Cp, there is the plasma concentration, and Cl 15 ml per minute, there is the clearance. So we will get elimination rate, that is 30 microgram per minute. So by using this equation, by previous penicillin example, assume that the plasma penicillin concentration is 10 microgram per minute. Now the concentration has been increased. Obviously if we consume some drug, it will increase gradually. So if the concentration is now become increased, then what will happen with the clearance? And as we have said, that whenever the concentration will increase, elimination also will increase. What was the elimination rate over here? Sorry, 30 microgram per minute. So now, according to this process, again we put that Cp here is right now 10 microgram per minute. And what was the clearance? Clearance is the same, as I am saying, clearance is the same, because the first order is following, because the elimination rate is depending upon the plasma concentration. It is not a zero order. So that's why here the 15 ml per minute same as a clearance. So in that case, what was the elimination rate? 150 microgram per minute. Whenever there was a 2 microgram per ml was plasma concentration, in that case the elimination rate was 30 microgram per minute. When it has been increased to 10 microgram per ml in this plasma concentration, in that case the elimination rate has also increases, 5 times has increases, 150 microgram per minute. So thus 150 microgram per minute of penicillin is eliminated from the body when the plasma penicillin concentration is 10 microgram per minute, and the elimination rate was 30 when it was 2 microgram per minute. So clearance may be used to estimate the rate of drug elimination at any given concentration. So if you know the clearance and if you got the plasma concentration, you will determine what is the rate of elimination right now, and is it is following the first order relation with the plasma concentration or not. That is the elimination rate are following the first order relation or not. We can determine through that. By who? By the clearance process. So clearance may be used to estimate the rate of drug elimination at any given concentration. So using the same example, if the elimination rate of penicillin was measured as 150 microgram per minute when the plasma penicillin concentration was 10 microgram per ml, we can determine the clearance. Again, by dividing that one. Now, see the next solution over here. Now, if you want to know a particular clearance for a particular patient by having a value of its weight, so what you will do, and you have only half-life of the drug, you don't know what is the concentration, and you only know that is the volume of distribution. So in that case, how will you able to find out the clearance? So here is whenever we will get the body weight, we know what is the half-life of the drug, and also we know the apparent volume of distribution. By applying this formula, we can determine the clearance of the drug. So according to half-life, we know that elimination rate constant K is equal to 0.693 by T half. So here is the T half is half-life is 3 hours. So 0.693 by 3 is equal to the elimination rate constant, that is 0.23 per hour. So clearance is equal to elimination rate constant into apparent volume of distribution. So according to that 23.1. So where is the patient weight is 70 kg. So for 70 kg patient, the clearance will be clearance into weight, that is 1617 ml per kg. So this is the way, if you know the weight of the patient, then what will be the elimination rate, and the clearance of the patient, we can determine. So the renal excretion, that means whenever the excretion will be done by the kidney. So what is this kidney? Kidney is nothing but the the key role of elimination organ in our body. So liver and kidney are the two key organs in the body that remove medications. The liver is done by biotransformation. So while drugs can be excreted in almost anywhere in the body, so the kidney is the primary excrement, that means excretion organ, for disposing metabolic waste product and plays a significant function in preserving the regular amount of fluid and the balance of electrolytes in the body. It is actually helping us in this way. So the kidney eliminates excess electrolytes, liquids and waste materials to preserve the salt and liquids equilibrium while maintaining the solutes required for the proper working of the body. So the kidney also has two endocrine system or endocrine function, that is renin secretion. Why it is secreting this? Which manages the blood pressure, and also erythropoietin secretion, which activates the development of red blood cells. So by activating the two processes, renal kidney also act as like an endocrine function. So now what is the anatomic consideration of the kidney? In the space of the peritoneum cavity of our body are placed for the kidneys in the back side. The exterior portion of the kidney is known as the cortex and the inside section as a medulla. So the nephron are the basic functional elements that jointly eliminate metabolic waste and preserve water and electrolyte equilibrium. So 1 to 1 million nephron are found in each kidney, and they are actually act as like a filtration process. Every nephron starts with the glomerulus that is present in the Bowman capsule. So every nephron starts with the glomerulus in the cortex, and cortical nephron have small Henle loops and are left alone in the cortex of large medulla related loops of Henle. Why it is so much large? Because from this portion reabsorption part is taking place. So Henle's long loops enable the nephron to recover more water by reabsorption and thus create more concentrated urine. So what is the blood supply? This is the anatomical structure, that is the longitudinal portion of the kidney, and you can see this is the medulla portion, this is the cortex portion, and the total on the outer surface there is the nothing but our capsule of the kidney, and these are the blood flow, that is the renal vein and renal artery. So roughly 0.5% of the overall weight of the kidneys are obtained, and about 20% to 25% of the cardiac output is going to kidney. So the renal artery supplies the blood for the kidney. Arteries supply the blood to the kidney. Vein will take out the blood. So the renal artery supplies the blood for the kidney, which break into the afferent artery. That means in different small capillaries. So this is the afferent arteries that passes through the kidney and branch into different arterioles. So afferent arteriole bring blood into the glomerular portion of the nephron, that is the Bowman capsule, where actually all the products are going into the within the nephron, within the kidney. So that is the afferent arterioles. So blood filtration takes place in Bowman's capsule in the glomeruli. So now the blood passes through the capillaries within the Bowman capsule into the afferent arteriole through a second capillary tubule, that is the capillaries with peritubules or rectivases, through the through the Henle tube, which reabsorbs some water. That means whenever the drug or the blood containing the drug entering into the kidney, that is through the afferent arterioles. When after filtration process the blood will come out from the kidney, that will through the afferent arterioles. Renal drug excretion. Renal excretion is a crucial pathway for certain substances to be avoided. Non-volatile medications that are water soluble, have low molecular weight, or gradually are biotransformed by the liver are generally eliminated through the renal excretion. So variation of the above may involve procedures for extracting medications from the kidneys as follows. What are these? Glomerular filtration process, active tubular secretion, and tubular reabsorption. These are the three processes followed by the kidney for the excretion purpose. So what is this glomerular filtration? Glomerular filtration technique is a unidirectional operation, and including undissociated, that means non-ionized, and dissociated, that means ionized medicines. So which takes place for most small molecules, less than 500 dalton. So protein bounded pharmaceuticals, that means drugs, behave as large molecules and are not dissolved in glomerulus. So the hydrostatic pressure inside the glomerular capillaries is the main motivating factor for glomerular filtration. And renal artery flow to the kidneys is extensive, that means near about 25%, and the hydrostatic pressure is very small. So a drug that is mainly removed by just filtration, that is no reabsorbed or secreted medicines, is calculated the glomerular filtration rate. That means inulin and creatinine are most used for this reason, because to determine the glomerular filtration rate, while creatinine is secreted as well. So the inulin clearance is approximately equivalent to GFR of 120 ml per minute. So the GFR's importance has a good association with the surface of the body. Pharmaceutical glomerular filtration is especially related to plasma concentration of free or non-protein bound drugs, because if the drug will bound the protein, it will become more macromolecular and it is not able to excrete it through the Bowman capsule through the glomerular filtration process. So the glomerular filtration for the drug increases proportionality, that is reducing the free concentration of medicine in the plasma and improving the renal drug clearance for other medicines. So what is this active tubular secretion? The continuous secretion of the tubes is a method of active transport. That means the continuous secretion of the drug is a method of active transport. In this, why it is saying active? Active means there is a requirement of carrier, there is a requirement of energy. So as a consequence, successful renal secretion becomes an energy transfer mechanism as the medication becomes transmitted across a gradient of concentration. So whenever there is a concentration, the transmission is happening against of gradient, across the gradient. So in that case it is active because the transport infrastructure is reduced in capability and can be overloaded. For the same carrier network, drugs with similar structure can compete. So among the active kidney secretion systems that have been established are those for weak acids and those for weak bases. So the p-amino hippuric acid and idopyrate are widely used in the calculation of successful tubular secretion because they have an ability to bind. So the glomeruli absorb these substances and the tubular cell secretes these substances. So the excretion half-life for a medication that is excreted exclusively by glomerular filtration will dramatically alter the plasma protein binding affinity. Obviously, in comparison, the binding of product protein does not have any effect on the half-life. Removal of the medication primarily released by active secretion. Why? Because as the attachment of pharmacoproteins, that means pharmacoprotein, that means pharmacological substances and protein, is reversible. So medications bound to plasma protein dissociate quickly as free medications are released into the kidney. So many penicillins, for example, are heavily protein bound, but their half-life isolation is limited. So successful secretion removes easily. So though being a more affinity to bind with the protein, but penicillin can able to excrete without any creating impact upon the half-life because it is dissociated so quickly. From whom? From the attachment with the protein. So what is the tubular reabsorption? Tubular reabsorption happens after the medication has been absorbed by the glomerulus and may be a mechanism that is consciously or unconsciously taken out into the plasma. So if a medication is reabsorbed entirely, the product's clearance benefit is roughly zero because it will not be able to clear. So clearance levels are smaller than the GFR of 120 ml per minute for medications that are partially reabsorbed without being secreted. But this is harmful whenever the drug will become more polar. So this is again subdivided into two types. What are these? This is the active tubular reabsorption. What is happening over here? This cycle is normally conducted via the body with high threshold organic substances and nutrients like electrolytes, oxygen, enzymes, amino acids, glucose. What is this passive tubular reabsorption? The concentration gradient that is driving force for such process is formed by back diffusion or because whenever the back diffusion is occurring, there is a concentration gradient is occurring, and this is act as a driving force of water with sodium and other inorganic ions. So by following this route, sometimes drug also may get reabsorbed within the body. So this is the second part till now, and the third part will come out with the factors that will affect upon the renal excretions and some other non-renal excretion processes that is involved with the elimination part. Thank you.